is a video lesson on Objective 4, Practice Test C of stoichiometry. This equation reads, Fe2S3 reacts with oxygen to produce FeO and SO3. Let's begin by creating the skeleton and then we'll work to balance. In the first equation, we would begin with, try to center this better, sorry. Fe2, try again, Fe2S3 plus O2 yielding FeO and SO3. We'll begin with trying to balance. I notice that I've got 2 irons on the left, 1 iron on the right. Might be a nice place to start, is placing a 2. 3 sulfurs on the left. I'll start with a 3 in front of the SO3. The irons and the sulfurs are balanced. Let's see what's happened to the oxygen. We have 2 plus 3 times 3 is 9. That's 11. There's no way to get an O2 to balance as 11. So back to the drawing board. Let's begin by doubling what we have found. Doubling will take care of the odd number. Instead of a 1 in front of the reactant, let's put a 2. Instead of a 2 in front of the original product, let's place a 4. And instead of a 3, we'll double to a 6. 4 irons, 6 sulfurs, let's recount the oxygens. 6 times 3 is 18, plus 4 more, 22. We would place an 11 in front of the oxygen. 2 to 11, 4 to 6 balances that equation. This equation proceeds with a 64% yield. It is only 64.1% efficient. How many grams of FeO, so our target product is the FeO, are formed when 124 grams of Fe2S3 react with excess amounts of oxygen? Our given is the first reactant, Fe2S3. Our want is the product, FeO, iron 2 oxide. When we begin, we'll need a molar mass of Fe2S3. I'll take that molar mass by adding iron. Iron weighs 55.8 times 2 plus 32 times 3 from the sulfur. I found a molar mass of 207.6. One mole of Fe2S3 said over 207.6 grams of Fe2S3. In the heart of our problem, we want over given. Our target product is our grams of FeO. Its coefficient is a 4 moles of FeO. Our given is the first reactant, 2 moles of Fe2S3. Since we want to land at a gram unit, we'll need a molar mass of the iron oxide. 55.8 plus 16, our molar mass, adds to 71.8 grams of FeO. When we find our answer, this will give us what's called our theoretical yield. If our reaction were 100% efficient, this is what we would expect to make. Let me hit 124 divided by 207.6 times 4 divided by 2 times 71.8. I found 85.77 grams of FeO as my theoretical yield. But notice our equation is only 64.1% efficient. What did we actually make? I'm going to take my theoretical yield and multiply that by 64.1%. In my calculator, I hit that as 0.641, and I will find my actual yield. I am only making 64% of the 85 I calculated. 0.641 times 85.77 gives me an actual yield of 54.98 grams of FeO. And that is the answer I would circle as my actual yield. And on the screen you can see I've circled 54.98 grams FeO is my final answer. How many liters of SO3 are produced when that reaction proceeded? We're just targeting that second product. It's the same problem, but we have the new product. 124 grams of Fe2S3, setting up my parentheses to target liters of SO3. This will tell us our theoretical volume of the product SO3. We would have the same first step as up above. Fe2S3 has a molar mass of 207.6 grams of Fe2S3. We want over given 6 moles of SO3 set over 2 moles of Fe2S3. To land at a volume unit, we use our molar volume conversion, 22.4 liters in every 1 mole of sulfur trioxide. When we start with 124 grams of our reactant, Fe2S3, we divide, ratio, multiply to land at the theoretical volume of SO3, our second product. 124 divided by 207.6 times 6 divided by 2 times 22.4. This answer on my calculator reads 40.1 liters of SO3. But remember, we're only 64.1% efficient. I have to take 0.641, 64.1% is typed in as 0.641, and that will tell me my actual volume of SO3 liters produced. 40.1 times 0.641 tells me 25.72 liters is the actual volume of SO3 produced. When we solve our stoichiometry problem, we get what's called the theoretical value. Since our equation is only 64.1% efficient, we type that in as 0.641 on our calculator. Taking 64.1% of the theoretical value shares with us our actual yield.